How do you load a variable? For example, x equals, or let's say this is y equals 10. How do you load this value into the variable y? Let's say y corresponds to x8. Okay. What instruction do you write to load this variable with value 10? Add I x8 and x0 and then 10. Okay, so that's correct. And this 10, we know that is represented in 12 bits. It's a 12-bit sign extended value. What if we have to load, because this register x8 is a 32-bit register, okay, and we are loading a 12-bit value which is sign extended. What if we have to load a bigger value which cannot be represented in 12 bits? What if it is a 16-bit value or 32-bit value? How we can load that 32-bit value into this register? We haven't studied this, so we are going to study there is a separate instruction for that, and which is called okay, so the same instruction here. So for example, we have to use load 1 2 3 4 5 6 7 8, which is represented in hex. So this is a hex value. One corresponds to these leftmost 4 bits, then 2 3 4 5 6 7 and 8. So this entire value is supposed to be loaded in a register which is a 32-bit register, but the value is also 32-bit. So there is a separate instruction which we call LUI, short for load upper immediate instruction. And the format is this: LUI already corresponds to the destination register, and this IMMD corresponds to immediate value. So it loads the upper 20-bit immediate value into a destination register. Okay, you're using assembler in your lab, so you can do the same thing with this format. Okay, now the 20 bits are placed into bits 12 to bits 31, and the lower bits are cleared. I mean, when you load a value, it loads the upper 20 bits. What happens to the lower 12 bits? It sets these values, these 12 bits, to 0. Okay? Any question here? So when we try to load a bigger value, we have to split it into 2 instructions. First, load 20 bits, and separately we can load the remaining 12 bits. Yes?
Why is it a problem that we have to put 32 bits into a 32-bit register? Wouldn't it be more of a problem for like 33 bits into a 32?
So starting from 0 to 32. 0 to 31, sorry. Are you referring to this slide? So the 0th bit, and this is the 31st bit. The entire value is 32 bits wide, counting 0 as the first bit. So what was your question again?
Is it you can't load that into a 32-bit register?
So we have seen an example before on the notes that add I x8 x0 10. So 10 is a value, decimal value, that you can represent simply in 4 bits, right? But what if you have a bigger value to be loaded in a 32-bit register? Okay, so it cannot be represented in, let's say, 12 bits. It's a huge value which can only be represented in 32 bits or 16 bits, for example. More than 12 bits it requires. So how would you load that data into the 32-bit register? This is what we are studying. Okay, just like this example, it could be a value, it could be representing some portion of an image or something else. Okay, everything, you just recall, everything is represented in numbers in computer, whether be it an image or a video or whatever. Okay, so how do we load large constants like this one? So if you have to load this value, the same value that we have just seen, into register x18, what do you think, which instruction we are going to execute first? So there are supposed to be 2 instructions. So LUI we have just learned, which can help us load the upper 20 bits, and then simply add I instruction, which we can use for lower 12 bits. So what we can do is we can load x18 with the upper 20 bits, 0, 1, 2, 3, 1, 2, 3, 4, 5, and each hex bit corresponds to 4 binary bits, so which is equivalent to 20 binary digits. Agreed? So these 20 bits can be loaded into x18. Next, we execute add I instruction by loading the remaining last three hexadecimal digit, which corresponds to 12 bits. Okay, and it will load the entire value 1, 2, 3, 4, 5, corresponds to the upper 20 bits, and 6, 7, 8. Can we execute the other way around? Can we execute add I first and LUI next for loading this entire value? Anyone? I got your answer. Anyone from that side? Can we execute add I? Because we are just adding, splitting the value into 12 bits and 20 bits. No? Why?
Because the LUI command, or LUI, whatever it's called, it clears the other 12 bits.
The first 12 bits, yes. So if we execute add I first, what will happen? So x18 will be loaded with this 12 bits, right? 6, 7, 8. And when we execute LUI next, then what will happen? This value, these upper 20 bits will be loaded, but LUI instruction clears out the last 12 bits. Okay? So it will reset the 12 bits to 0. That is why we cannot execute LUI later after add I. Okay? Get it? So first of all, we need to load the upper 20 bits and then the remaining 12 bits. Okay?